Okay, and just like that, we're on another update. Today I'm going to do the same thing as I did last time and just briefly describe what has happened, and then the later part of the video will be how it was all done. But today I'm just describing, of course, what I did is make the swing arms and mounted the brakes. And I even put the axle in. So now all I need is a big motorcycle sprocket, like right here maybe in here. I'm not sure how big it is. Seriously, to turn all this, and I am just kidding. This is just an alignment bar so that when I made the swing arms, they'd be all lined up, because it's kind of critical. There's this, the thing that was real critical was making this 90 with that, and it all lines up so the tire's in the right place. Is this even gonna work? Even though I do have a little adjustability in there, you want to get it as close as you can. They needed a fixture to make sure that they don't bend and warp when they're being built, because all the heat warps things. And even though I have some adjustment in there, you want to get it as close as you can, and so that you're not at the end of your adjustment. So I'll show you how this all works, and I'll probably edit this part because it's crappy. So you'll see in the video that I use a fixture because all of the heat generated by this warps things and changes its direction. So you need some fixture that's very strong to keep it all in place. The next on the project, next on the docket is the rear motor mounts, which will be a tube from here to here, and then from here paralleling that up to here, and that'll be braced in. And then from that tube, this is going to fail miserably. I don't talk a lot during the video, so if you have any questions, just leave a comment and I'll answer it. If I don't know the answer, I'll make up something. Yeah, so you shim the disc in there, the caliper, and you get it as shimmed as best you can, and then when you start welding it, it starts moving around, and then when you're all done welding it, then you just tap the ears to where you have the same gap on both sides of the disc brake pads. So I made a template for the trailing arm, and I retraced it here to give a little extra dimensions places I wanted. And then I made this out of 125 chromoly sheet and bent it in the slip roller. So this is, I got to do some work right here, and I'll show you. Okay, so the temporary control arms are made, and I need to take them out so that I can weld them on a fixture. There's just not really any room to weld it on the car, which would be optimum, but in order to get that out and secure on a fixture, I need to make some temporary, just some plates to hold everything in alignment so that I can put it on the fixture outside. This had to clear, the disc brake had to go in back of the control arm because it has to be up and down to bleed, so I couldn't put it on top like I originally wanted. So it just makes this area kind of busy, but it's fine. Also, when welding on something with bearings like this, make sure you put your ground on the piece that's going to be welded, or else you're going to arc the bearings. So now I need to just support this end, and we can start welding it. Don't know how I got it perfect without the first time, but it is. So talking about the force that this arm will have on it, there's really only push and pull, because there's a rod end at this end, so it doesn't have to worry about twisting this part. It's mostly the thrust of the tires moving forward they're going to put stress on this bend. So I was thinking I could make a port right in this bend area with a sleeve, which would be similar to this sleeve, so that it has two more horizontal planes going this way, and that would be a total of 4 horizontal planes, which helps keep this from bending back and forth. Not a big port, just something like that. However, the problem is I would take a 1.5 inch 120 wall tube, cut it in half, and then just plate these parts, and then this would be 3/4 inch chromoly cut in half, and then join them. So what this means is that the seams between the tubing and the plate have to be welded right here all the way across. And the problem is, this is the smallest torch I got, and it may work to weld that. See, it's got to fit inside that hole and going this way, but this one is way too tight to really get your torch in there and, you know, move it to halfway at least. I mean, it's possible, but it doesn't look good. So I can make the port bigger, wider, to make this fit, but I don't want to give up too much of this room away. I could weld just the outsides and then slide the whole thing in, but the insides wouldn't be welded, and it would look pretty crappy, I'm pretty sure. So I'm not sure what I'm going to do there. The other alternative is, instead of making this 1/8 inch plate top and bottom, make a 3/16 plate top and bottom, and that's essentially like adding one more 1/8 inch. It's like having 3 1/8 inch plates on the horizontal. That'd be the easier way out. We'll see how this goes. Okay, we decided to just put a mid plate in there. So that's 125 mid plate, just to strengthen that bend. Time to flip it over and get the other side. Getting ready to weld the top plate on, and we'll use the same gaps right here, and then right here I've remove material so that I can attach to the bung on the edges right here, and then I'll weld right here. Oh, come on, man. I run 185 amps to weld the 125 to the 250, and 120 amps to weld the 125 to itself. To weld the plates to the bung, I'm going to use 195 amps, try that, and use 3/32 rod to fill in this big gap. Now it's hard to tell, but if you look going down that plate, you can see that the whole arm shrunk about a 1/16, 32nd, maybe 32nd to 16th of an inch. Pulled this way as everything shrunk, which I knew it would, but that's why we have adjustable rod ends. There's one. I know. Let's show some more welding video. Weld, 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 weld.